Around 1991, I had the idea that if you made a car very light and crashworthy out of advanced composite materials and gave it very low aerodynamic drag and rolling resistance, and then gave it hybrid electric drive and radically simplified design, very rich in software, you would end up with what I call a hypercar that could be about 3 to 6 times as efficient as a regular car, depending on whether it ran on an engine or an engine hybrid or a fuel cell. And I thought this could be done at a competitive cost. Initially, I spent a couple of years exploring the concept with General Motors, who graciously took my car education in hand, and then put it out more widely by putting the concept in the public domain so nobody could patent it, and then getting them all fighting over it. By 2000, on the order of $10 billion had been committed to this general line of development. Meanwhile, in '98, we'd assembled a consortium of 17 firms, mostly Tier 1 automotive suppliers, and hired Lotus Engineering to do a feasibility study. They said, yeah, you could make a car that would pretty much do that, and it would be attractive. And some of our partners said, well, let's make a business out of it. So in '99, we did Rocky Mountain Institute's fourth for-profit spin-off, Hypercar Inc., which I chair. In 2000, together with a couple of Tier 1 engineering firms, we designed your basic uncompromised mid-sized suburban assault vehicle, a mid-sized SUV that would get 66 miles a gallon as a gasoline hybrid or 114 miles a gallon equivalent as a fuel cell car. But it would seat 5 adults in comfort, 0 to 60 in 8.2 seconds. It could haul a half ton up a 44% grade. It would do everything you'd expect a very peppy luxury SUV to be. We initially entertained ideas of becoming a niche producer of such cars, but there was no way to raise enough capital to do that, even though it takes a lot less capital than normal automaking. So we decided to become an intellectual property company and license the key technologies to the industry. Then a couple of years ago, the automakers started to come to us and say, well, now we understand why we need to make cars out of carbon, and we haven't really got to know that much about carbon before because we're really metal stamping companies, but we're getting really interested in it. The trouble is we don't know how to do it cheaply. If you've figured that out, we want to talk to you and make us some parts. So in summer 2003, we stood up a lab in Glenwood Springs, Colorado, to test what's called the fiber forge process we'd invented and patented. Here's an early sample. It's over a year old, just in the shape of a cup for illustration. But this is 58% carbon fiber embedded in nylon, and it's made automatically under digital control by something you might think of as an inkjet printer for carbon fiber. But it lays these and other fibers in just the positions and orientations and layers you want. It makes a flat blank, which you then put in a heated die and form into the net shape you want. And it's extraordinarily strong and light. Of course, in aerospace, they use such materials already, or in Formula One cars, but it's all handmade and very expensive. And we think we've figured out how to get at least 80% of the performance of those handmade structures in an automatically made structure at less than a fifth the cost. Now, the company, now under the name FiberForge, is commercializing this process, and it still is not a mature process, but we've overcome the basic hurdles and are making 1 meter square parts that are being tested by automakers and their suppliers. We have early customers, and it's the usual struggle of a undercapitalized startup, but I think coming along very well. And we're not the only ones doing this, of course. The August 2004 issue of Automotive Design and Production magazine features 2 companies bringing competitive carbon fiber into the auto market. One's BMW, which is making thousands of carbon roofs a year and is rumored to be about to introduce a whole carbon car. And the other one is FiberForge, our little outfit, in the automotive mecca of Assault, Colorado. as the article puts it. And there are others as well. Honda and Toyota have gone into the carbon fiber airplane business, probably not for amusement. It's a good way to learn how to make things out of carbon fiber in a high-value, low-volume niche and then migrate it back to cars. So we're very encouraged by how this is going. And in the past year, in a new book co-sponsored by the Pentagon called Winning the Oil Endgame at oilendgame.com, we've shown that actually the ultralighting, cutting the weight of the car in half but making it safer, and cutting the size of the engine by threefold or so, that turns out to be about free, because the smaller engine to run the lighter car and the simpler manufacturing when you're using these materials about pays for the costlier materials. So instead of, say, a 55-mile-a-gallon Prius hybrid sedan, you could make that about 92 miles a gallon at the same price, and it would pay for itself from fuel savings in just 3 years. That's very encouraging. It's a whole new design space the industry didn't know was there, because until we had the proprietary production cost data for this SUV concept car designed in 2000, nobody really had a good handle on what it would cost to make a highly integrated ultralight carbon car, let alone an SUV, something at the heart of the market. So that's turned out to be a very useful exercise.
So we could look forward to a carbon-based car in the not too distant.
I think it's realistic that to expect manufacturing could ramp up as early as 2010. Some companies might do it faster. The rumor in the industry is BMW might do it in 2005, but I can't confirm the date. And it's also not the only solution. The steel industry has meanwhile developed some special alloys and heat treatments that can do most of the same thing with light steels, and everyone knows how to make cars out of steel. This turns out to be a realistic backstop technology in case the carbon fiber solution isn't ready yet.